Hi everyone, we are moving on to polynomial unit. Let's start with chapter 5.1, multiplying polynomials. First of all, we did a quick review on polynomials, and we talked about how polynomial consists of one or more terms which are separated by plus or minus signs. And also, monomials is a number or a variable, or the product of numbers and variables. It is a polynomial with only one term. We also talked about binomials. Binomials are polynomials with two terms. For example, we have x plus 5, or we can also have negative 2x squared plus 1. Trinomials have three terms. For example, x squared plus x plus 1, or x plus y plus 1. Let's go over the parts of a term. We have numerical coefficients. In short, I call it coefficients, and that's good enough. Those are the numbers in front of variables. And the variables are usually an alphabet that represents some unknown value. Degree of monomial. The sum of the exponents of its variables. So for this example, we can see that 2 times a to the power of 1 times b to the power of 3. We just need to add those exponents to find the degree of a monomial. So we have degree 4. Another term to go over is the degree of a polynomial. It is the degree of a term with the highest degree. So when we refer to monomial, we only have one term. This is one term, but we can see that there's three terms here. So we'll have to check the degree of each term, and we have to pick the highest degree, and then that would be the degree of a polynomial. So we have degree 2 for this term, and then we have degree 1, so 2 here, 3 here, and then we have 1 here. So the highest degree we have would be 3. So the degree of this polynomial would be 3. Complete the following table. We have the polynomial expression. We just need to find the number of terms, degree, and type of polynomial. So let's start with type of polynomials. We know that there are 1, 2, and 3 terms, so we know that this will be called trinomial. Trinomials have 3 terms. And lastly, when we're looking for degree of a polynomial, we need to check the degree of each term and pick the highest one. So let's take a look at 2a. So we have degree 1 here. 4b has degree 1 as well. And 7c has degree 1. So the highest degree would be just 1. Next example, we have 1, 2, 3, and 4 terms. This is called polynomial. But there are 4 terms here. Let's check the degree of this polynomial. We have a degree 3 for the first term, and we have degree 2 plus 1, 3 on the second term. We have a degree 2 on the third term, and degree 0 on the last one. So the highest one is 3. Moving on to next page, multiplying monomials review. First thing we need to do is to recognize coefficients and variables we can multiply. We have coefficient 5 and 7 here, and we have a variable x here. Let's rewrite this in an expanded version. So this would be 5 times 7 times x times x. This is just 5 times 7 is 35, and x times x is x squared. Notice that we could only multiply the coefficients together and variables together. Next question. We'll do the same thing. We have 2 and 5 as coefficients, and we have x and y as a variable. Let's write this again in an expanded version. So we have 2 times 5 times x times y. I know that I could multiply 2 and 5 together. So this would be 10. And x and y, we cannot mix them together. We can't multiply them, so we just put them side by side. So the answer would be 10xy. Multiplying binomials. Method number 1. We can use algebra tiles. Before we move on to example 2, let's quickly review what algebra tiles are. So we have a filled-in square. This represents positive x squared. And blank square would be negative x squared. So the unshaded ones represents negative values. We have a bar like this shaded in, and this represents positive x. And mini square filled it in, this represents plus 1. And the unshaded one follows with a negative sign. We're going to use this tile to represent the multiplication of two binomials. 2x. So basically this is an x bar and this is another x bar. So in total, this is 2x. Same here, this is an x bar, and notice that this is unshaded mini square, that is negative 1. Just like this one. So essentially, we're looking for the area of rectangle. So let's fill it in. All you have to do is just draw corresponding length on this each side. This is x and this is x. So this is shaded, and we know that this will be called x squared bar. We have another positive x squared bar here. And we have unshaded x bars. So these would be negative x and negative x. All you have to do is add these tiles together. And so this, we can say we have 2 of x squared tiles, and we have 2 of negative x tiles. So we can see that this is the product of that expression using algebra tiles. We're going to double check by using method number 2, distributive property. So in this case, the diagram tells you to distribute the first term into the second term. I'll show you why they have the arrow there. So we have here 2x times x. So first thing was distributed into the first term of the second bracket. We keep the operation the same, minus and minus here. And then we're going to distribute once more, 2x times 1. We get 2x. Let's combine the x's together. So 2x squared minus 2x. So you can see that that is what we got from example 2 using method number 1. Moving on to next page. Example 3. Use a distributive property to multiply the following. Part A. 4 times 15. So we all know how to multiply this without using a distributive property, but I wanted to show you that distributive property works even in this case. So we have 4, but we also know 15 is 10 plus 5. So let's rewrite that into an expanded version like this. 10 plus 5. Try using the distributive property to expand. We have 4 times 10. 4 times 10. We keep the operation here, so we're going to rewrite it, plus, and we're going to multiply 4 and 5. We get 4 and 5 here. So we have 4 times 10, which is 40, and we have 20 for 4 times 5. It results in 60. And if you punch it into a calculator, 4 times 15, you'll see that you get 60. So distributive property is true in all cases. Let's take a look at the second example here. We have -2 as a term to distribute. You first need to distribute to the first term and then second term. Let's rewrite that. This is equal to -2 times 3x. Keep the sign here, so minus. And we have -2 times 1. This equals to -6x. This turns into a positive, and we're left with 2. That's one way of thinking about it. There's a second way to do this, and it is to leave the negative alone. So from here, and just multiply the 2 into the brackets first. We have negative. You need to keep the bracket. 2 times 3x. Keep the operation negative. 2 times 1 is 2. We're going to simplify this. Keep the bracket for now. We have 6x minus 2. And then what you're going to do is apply this negative into each term again. Then we'll get -6x, and then we'll get negative times negative, which is positive 2. So you can see that either method works, but the second method uses distributive property twice. Let's take a look at part C. So I'm just going to multiply the entire first term into the bracket. We get -8a times a. Keep the operation minus -8a times ab. So we get -8, and there's 2 a's here, so a squared, and negative makes a positive, so we have positive 8a squared b. So let's take a look at binomial times binomial case using law of distribution. So when you're multiplying two binomials, you need to distribute twice. So the first term here is a by multiplying c and d. Okay, so we have ac, ad. We have a second term, b. We're also going to distribute by multiplying into the second bracket. So we have BC and B times D. And then you add them up. We also call it, in short, foiling. So you take the first term in each bracket, so A times C, and then you take the outside terms A and D. Inside terms, B and C. And last term in each bracket, B and D. I like to memorize it using the arrows like this with the direction. But if FOIL works better for you, you may totally use it. Let's try our example 4. Determine the product. Part A. Let me draw the arrows first. So when you're foiling, you take the first term, you multiply the first one, and then the second one. Take the second term, multiply with the first, and the second in the second bracket. I'm just going to rewrite this. So x times x, x squared. We add them. X times 2 is 2x. We have 1 times x, which is x. Lastly, we have 1 times 2, which is 2. Let's simplify a little further. Collect the like terms. X squared doesn't have any like terms, so I'm just going to leave it. I see x and x here, so I can add the coefficients. So we have 3x and left over 2 here. Part B, 3x minus 2 all squared. This squared is not something we can distribute to the expression here. Don't do that. That's incorrect. That exponent tells us that this expression is technically written this way. Okay, you're multiplying 3x minus 2 twice. All right, so let's use distributive law. So we have first term first, second term here, these two here, like that. So let's expand it. We have 3x all squared plus 3x times negative 2. Okay, so this is negative, this is negative, so we have to multiply the negative 2 here, plus second term and the first one here. So negative 2 times 3x plus negative 2 times negative 2. We have 9x squared and negative 6x here. And we have another negative 6x. And negative 2 times negative 2 is positive 4. We're going to collect the like terms. We have these two terms because they both have x. We have 9x squared minus 12x, and then plus 4. And I'll show you why having this exponent 2 distributed into the expression is incorrect. This is wrong because we get 3x all squared minus 2 squared, which is just 9x squared minus 4. So you know this is incorrect. Incorrect. Please do not try to distribute if there's an operation like this inside the base, plus or minus. Okay? This only works when it's a product. Power of a product is good, but not this. Moving on to part C. Let's start with distributing the first term 2 here. So we have 2 times that and 2 times the second term. So we'll do this step by step. Plus 2 times 1 is 2. And I'm going to just bring down the rest of the expression. And then we're going to do another distribution. We have 4x all squared plus 4x times negative 5. So this negative stays with the 5, plus 2 times 4x plus 2 times negative 5. We have 4 squared. So notice that this also gets distributed. This is a power of a product. Okay, so therefore we can actually distribute into the base, saying 4 squared, which is 16, and then x squared is x squared, and minus 20x plus 8x minus 10. We have like terms here, so we can simplify. We'll add the coefficients together. So we have 16x squared minus 12x minus 10. So this is it for 5.1.